Welcome to the Extraction Tech 1300 basic operational video. In this video we'll cover all basic operating principles of the 1300 from start to finish, as well as safety and maintenance procedures. So step one is we're turning on the water circulator unit. We're pressing the blue power button here, checking our set point is at the temperature we desired, that our play button is highlighted, and we're hitting enter to start the actual flow. This is our mode 1 water circulator configuration. So our main water inline, color-coded white on the hose, and the corresponding port is coming into the bottom of the expansion filter. And then our main water outline is coming out from the color-coded yellow port back to the water circulator, completing the loop, which is in the mode 1 configuration. Extraction Tech recommends using material socks to load and run your material in. Big time saver between runs, cuts down on the mess. So here is a pre-packed material sock ready for extraction. We're going to load this sock directly into our extraction vessel. Pretty straightforward. The sock enters the column and we gently fit it in the tube and insert. It's pre-sized to fit in there. Once we've loaded the sock into the material tube, the next step is we need to clear any debris from this top ferrule here. A small paintbrush or a Q-tip is best for doing this. So if you see all my debris from the sock, just a few swipes with my paintbrush can wipe away most of that debris and give me a nice clean seal to keep going with. Once our material sock has been loaded, we can move to the next step, which is going to be inserting our 4-inch perforated disc gasket on the top of the extraction column. One important thing with these gaskets, and really all gaskets in the system, is maintaining a good amount of lubrication. So usually at the beginning of the day and the end of the day, you're going to want to run some light coconut oil just to film. If you're seeing big chunks of coconut oil you're using too much, just a light film of that coconut oil around all the gaskets goes a long way in keeping them hydrated and maintaining their quality. One thing we look at every extraction is, just like we checked on our ferrule here, is we want to make sure that this gasket is completely free of debris or any large chunks that could affect its sealing performance. So this gasket's in good shape. I've already lubricated this gasket. So I'm going to insert the gasket onto the ferrule seat of the extraction column. Kind of hard to mess this up. It's only going to fit in there one way. Once I have this gasket set, the next step is going to be putting my top cap on top of that gasket. Now the top cap has a similar ferrule to the bottom of this that we've already looked at, and we also want to make sure that this is very clean and free of debris. Pretty rare you'll have a lot of buildup in here, but it's still something that should be checked, and then use a paintbrush or a Q-tip just like the other ferrule to remove any debris if they're present. If that all looks good, we can assemble the whole assembly together. So now we can see how everything's connecting. Our gasket's in the middle, and to really make this connection tight and seal, we need to apply our 4-inch high pressure clamp. We need to look at these clamps and understand that we have a notch side on the clamp and a flat side on the clamp, and both sides will have one of these each. This is a correct assembly because we have a notched end on one side and a flat end on the other. If I was to see a clamp like this, where I have a notch on both sides or a flat end on both sides, it's an incorrect assembly. The clamp should never be assembled that way. And the reason they look like this is because when I go to put the hardware into the actual clamp, I'm going to have my stainless steel hex bolt, and the head of that hex bolt is designed to sit right in this notch. So when I put the bolt into the clamp, I want to make sure that the bolt head is sitting flush with this notch, not riding over the edge like this, but nice and flush with the notch of the clamp here. On the other side of the clamp, or our flat side, we'll have our small lock washer, which goes onto the threads of the bolt. And then we'll have our brass nut, which is going to come behind that. And eventually, that's what's going to tighten down and actually compress the clamp onto the vessel. Now we're going to look at assembling the 4-inch high pressure clamp onto the actual extraction vessel and top cup. So here I've got half of the clamp. I already have a bolt through the notched end of the clamp. I'm going to simply attach that around, secure it on the back end of the extraction vessel and top cup. You can note that I have the hex head of the bolt is sitting flush in the notch of the notched end of the clamp. So that tells me that when I go to put the other side of the clamp on, I know that I'm going to need the flat side in opposition. So I've got a nice notch to flat happening. Once I've got that other end of the clamp on, it's as simple as putting on my small 3/8 lock washer and then my bronze nut. And we're not really worried about tightening anything at this point yet. We're just getting the hardware on the clamps. So the same thing I did on this side, I'll do on the other side of the clamp. I'm going to have my stainless steel hex nut, and the head of that is going to go right into the clamp, sitting flush with the notch in the clamp. And then my lock washer will go onto the threads, and then my nut right behind that. So now that our 4-inch high pressure clamp is assembled onto the extraction vessel, I'm going to finger tighten both sides of the clamp, trying to maintain an even gap between the actual gap in the clamp. So to do that, I'm just going to simply turn each nut, kind of keeping an eye on the size of that gap in between. There's going to come a point when you really can't do it with your fingers anymore, and we need to switch to a wrench. So I've about reached that point. So I'm going to grab my wrench. The system wrench comes with the system. It's 5/8 ratcheting on one side, 3/4 ratcheting on the other for whether you're working on the extraction vessel or the collection vessel. And to tighten the clamp down, I'm simply going to do a couple turns on this side of the clamp, 2 or 3. And I'm going to come to the other side of the clamp and do the same thing. And it's all about just trying to tighten the clamp down evenly and maintain a nice even torque on both sides. Now, to ensure this clamp is tight to what it needs to be, I'm going to use a torque wrench, which looks like this. And this is a device that you can set to stop tightening and give you a signal. So the correct setting for all the clamps on this system is 20 foot-pounds of torque. So you need to make sure whatever torque wrench you have, you buy, you get, it's set to 20 foot-pounds of torque. So all I need to do to use it is fasten on to the same nut we were tightening with the other wrench. And I'm going to go gently down a little on this side, same thing on the other side. The next step in the process is we're ready to connect the system flow lines and begin vacuuming down the system. So to do that, we're going to grab our 4 solvent hose. I'm just going to put them behind my neck for now to make it easy. And the first connection we'll do is the red hose. So everything's color coded for ease. I'm going to go connect red to red. And I'm just going to kind of let this hose dangle out securely over the top. The big thing with the hose is you just don't want to let them touch the floor. You don't want to be stepping on the hoses. It can lead to damage. Someone could trip over it. Someone could pull the rack down. So just keep it up out of the way for now. The next system hose we'll connect is the green hose. That's going to go from the valve 3 quick connect, color coded green. And the other end of that hose will plug into the corresponding green quick connect on the back of the actual expansion filter. So the next system hose we'll connect is the Brazil hose, or the yellow and green hose. One end of this hose is going to plug into the corresponding color coding in the front of the expansion filter. And the other end eventually will plug into the inlet of the recovery pump, but for now we're going to pull vacuum with this hose, and we're not quite ready to do that yet. So for now, I'm just going to let that hose kind of hang out on the rack. Same idea as the red hose. It's secured on the rack somewhere. It's not on the floor. Nobody's going to step or trip over it. Okay, so the next step towards pulling vacuum on the system is we're going to come over to our wall mount over here and use our air tool port, which is connected directly to this blue hose, which will eventually power the vacuum pump that we'll look at momentarily. First, we'll just talk briefly about this wall mount. So here I have a 1/2 inch drop that's coming all the way from my air compressor in another part of the facility. That compressed air comes down a couple T assemblies. One of those is a gauge so that we can read our compressed air NPSI and constantly know what that level is at any point. The next part is the blue hose that will connect and power our PAB air-driven vacuum pump. And the last part is a yellow ball valve that will actually control the flow of compressed air to the recovery pump. So with that being said, let's look a little more at the blue hose and how this connects to the PAB. So one end of this blue hose, I just have a male to female basic air compression fitting. So as I plug that in, I pull back on the disconnect, and now it's locked in. It's going to be the same thing on the other end of this hose. So if we go down here to the ground, I've got my PAB air-driven vacuum pump. And to power this pump, that's very basic. I'm going to take the same fitting I just saw up at the wall. I've got the same fittings on this pump. So I'm going to slide back my air quick connect, plug that onto the male plug version of that. And once I'm plugged in, I've now powered the PAB with compressed air. And my ball valve lever here is what will actually control the flow on and off and power the actual vacuum pump. Anything being exhausted or pulled out of the vessels we're vacuuming is going to be coming out of this black assembly here. So as a safety precaution, we always need to be pulling vacuum with the PAV directly near or at your air vent leaving the room. So if for some reason there were residual solvents being pulled out of the pump, they'd be mitigated through the ventilation and everything's okay. So with that being said, let's start pulling vacuum on our system. So to do that, I'm going to pull my Brazil hose from the system and plug that into the corresponding Brazil port on the PAV itself. So now that the PAV is on and actively pulling vacuum, we need to make sure that all three of the system ball valves are open so that we can pull vacuum in each of the vessels. So we're going to open up valve 3, we're going to open valve 2, and we're going to come to the top of the extraction column to open valve 1. At this point, now we're pulling vacuum in the whole system as a whole. So we're going to let this run for about 2 minutes, and we can actually see our vacuum levels in each system gauge, as well as the vacuum gauge on the PAV itself. So now that we successfully pulled vacuum on the 1300 and isolated all the vessels, I'm going to remove my Brazil hose, and I'm going to couple this directly to the corresponding color code, which would be the pump inlet on the Haskell recovery pump. So I'm going to plug Brazil to Brazil, and we're done there. The next thing we need to look at is the last flow line in the system, which we talked about earlier, and that's going to be our blue flow line, which is never actually connected to the 1300 itself. It's always going to be just a discharge line from the pump or a transfilling line. Since it's new and has atmosphere in it, we need to pull vacuum on this hose before we use it in operations, and we also need to pull vacuum on the discharge side of the Haskell itself. So to do that, I'm going to use the PAV again, and all I need to do is direct one side of the blue hose to the PAV vacuum pump itself and connect the other end to the Haskell blue port or the discharge port. Once I do that, I'm going to move my vacuum pump closer under my ventilation again, and I'm going to re-engage the vacuum pump by flipping the yellow ball valve up. As soon as we did that, in almost no time at all, we can see that our discharge gauge is now reflecting vacuum. So to end the vacuum, I'm going to disconnect my hose first from the PAV, then I'm going to turn my vacuum off. And now with this blue hose, what we can do to prepare for our recovery in the end of the run is I'm going to plug this directly into the vapor port on my recovery tank. So our actual operating tank with our solvent we're using for the extraction is located in the 7-gallon bucket full of ice, and it's already set at our charging scale, which is a Class 1 Division 1 explosion proof rated scale, and we're going to track the solvent we're injecting to the system when we get to that point. With that being said, our solvent tank's sitting in ice, so it's going to be at a more compressed liquid state at a lower PSI, and if we were just to plug that in directly to our extraction column, it would be difficult to get the solvent to actually flow into the column. So that's where this secondary tank in the hot water bath comes into play. This tank is always going to be a 10-pound tank of instrument grade propane. Reason being, propane is a much higher resting pressure. In a hot water bath, it has even more pressure. So basically what's going to happen is we're going to use the vapor pressure from our propane tank to push into the vapor side of our actual operating tank, and once that vapor pressure is pushing down on the liquid solvent in our main operating tank, that's going to compress the liquid solvent in the bottom of the tank, and we're going to pull solvent through the red line or dip tube side of the tank, and that will allow a continuous flow of liquid solvent into the extraction vessel. So to make that hookup, we're going to use our same blue solvent line, which we've already pulled under vacuum, and we're going to simply connect that from our vapor port on our pressure assist tank to our vapor port on our actual operating tank. So I'm going to ensure that both valves are closed. My blue valve on the assist tank is closed, and my blue valve on the operating tank is closed. So at this point, I can couple my blue line to their corresponding blue ports. So I'm going to plug blue to blue here, and then I'm also going to plug blue to blue here on my operating tank. So now that we have our line connected to the two vapor ports of our tanks and our valves are closed, We're ready to prepare for the actual liquid injection by getting the red hose from our top cap, which is located at the top of the extraction vessel. And we're going to plug the red hose into the corresponding liquid port on the operating tank for the solvent we'll be charging in. So red plugs to red. I've ensured the valve is closed. And now we're truly prepared to actually begin the recovery. So to do that, I'm going to open the blue twist valve on our back pressure tank simply by twisting open. And I want to open this wide open until I can't turn the valve anymore. We never want to force these valves. Once they're open and you can't feel it anymore, don't push it past that. And the same is true when closing the valves. When you feel the valve shut, don't try to crank it down anymore or you can end up damaging the valve. So now that I have the pressure assist tank vapor valve open, I'm going to open the vapor valve on the actual operating tank as well. So as we can hear, now we have vapor pressure pushing in and compressing the liquid solvent in our actual operating tank. Once I have those open, I'm going to open my liquid valve on the operating tank. And this is going to actually run liquid solvent all the way through our red charging line. So I now have liquid solvent running all the way through my red line, terminating at the ball valve at valve 1. So now that we're ready to inject solvent into the system, we have our solvent tank in ice in the 7-gallon bucket on our Class 1 Division 1 explosion proof rated scale. This is the readout to that scale, and it's telling us that the hose connected into the tank in the ice with the bucket weighs 43 pounds. So on the 1300, we're going to charge 5 pounds of solvent into the extraction column, and the only way to track that is by weight. So as soon as we open our red ball valve, we're going to see the pressure rising on our valve 1 gauge, and we're also going to see 5 pounds of solvent be negated from this number. So now that we've got everything in order, we're going to slowly open our red valve, valve 1, and that's going to introduce liquid solvent into the extraction unit. As I'm opening valve 1, we can see the pressure rising on our gauge, and we can see our scale tearing down at the same time. When we get to 38 pounds on the scale, that will let us know that we've injected 5 pounds of liquid solvent. When we hit 38 pounds, we're going to turn the red liquid valve at the operating tank off. So now that we've hit our 38 pounds, I'm going to close the liquid valve on the operating tank to completely shut the flow of solvent into the extraction column. Now that we have the required 5 pounds of solvent charged into the system, we're going to prepare the system for recovery so it's ready by the time we get there and we can get some clutter freed out of the way. So the first thing I'm going to do is I've already closed my red ball valve to shut the liquid flow into the system. Now I'm going to close my 2 vapor valves that I was using for the pressure assist. So I'm closing the blue valve on my operating tank and closing the blue valve on the pressure assist tank. Now that the pressure assist tank has done its job, I'm going to disconnect my blue line after I've closed the blue twist valve, and I'm going to reroute this directly to the discharge of the Haskell recovery pump. Since we're already plugged into the blue valve on our operating tank, this will prepare the tank for recovery completely. So now that I've ran my blue line back from my pressurized tank to the Haskell, I can connect that to the discharge port of the actual Haskell recovery unit. One thing I need to make sure of is that my blue line coming back to the operating tank, that twist valve on the vapor port is wide open, or we're going to be stalling out against the quick connect because there will be no pass through into the actual tank. So by opening the valve, this is going to do one of 2 things. One, it's going to allow flow back into the operating tank, and 2, I'll have a direct reflection of the operating pressure in this tank on the discharge gauge of the Haskell itself. Now I'm going to disconnect my red solvent hose from our operating tank since we're done using it, and I'm going to coil this up kind of how I had it before we started. so that we can recover all the liquid solvent out of this line as well. Again, you just want this hose hanging out around the top cap, just so that it's not going to be dangling on the floor or getting in the way or damaging anyone or getting stepped on, etc. So now that we've charged our system with the 5 pounds of solvent and washed all of our material in it, we're ready to drop our liquid solvent and all the extract dissolved into it into the collection vessel, which will then be boiled off, and what we're left behind will be our concentrate. So the first step in that is we need to open valve 2, the black ball valve. When I open this valve, we're going to see the gauges between gauge 3 and gauge 1 equalize. So I'm going to open valve 2. And now we've dropped all of our liquid solvent and extract into the collection vessel. And then you'll notice the gauge 3 is reading about 50 psi. I should be about the same up at gauge 1 on the top cap. I'm going to give that about a minute to 2 minutes just to be sure that everything's dropped down and that the pressures have truly equalized. So the next step in the process, now that we have all of our extract and liquid solvent in the collection vessel, we're ready to start recovering the solvent. To do that, we open the green valve, which is also known as valve 3 on the collection vessel. One of the most important things with running the 1300, this green valve always needs to be opened very slowly. Opening this valve rapidly creates a volatile condition inside of the collection vessel. The liquid solvent bounces, splashes all over the place, and you actually run the risk of pulling some of that liquid solvent through the line into the expansion filter, in extreme cases all the way back to the actual inlet of the recovery pump. By opening the valve very slow, we can prevent that from happening by just taking the vapor out of the top of the collection vessel and keeping the liquid in the calmest state possible at the same time. So when I open valve 3, we're going to talk about briefly the flow line that's happening when I do that. As soon as I slowly open valve 3, it's going to route all of our solvent, which should be mostly in a vapor form at this point, to the back of the extraction column here, or excuse me, the expansion vessel, and it will have to expand into a heated chamber. So if there is any liquid solvent at this point, expanding into a heated chamber will convert that solvent to vapor, and if there's any concentrate that's been carried over this point, it'll be collected in this small 2-inch receiving cup on the bottom of the vessel. After that, all of that heated vapor will rise up through the vessel, pass through a small porous filter, then it'll exit the front of the expansion filter through the Brazil hose, and that Brazil hose will track all the way to the inlet of our Haskell recovery pump. The Haskell recovery pump will take that vapor, compress that back into a liquid state, and be pushed out of the discharge blue line back to our original operating tank over here where we started. So now that we've started the recovery process by opening the green ball valve slowly, we're ready to start recovery with the Haskell pneumatic pump. To do that, we need to go on our dial regulator here, and we'll open that up to 10 psi. One way I know that this pump is ready is I know my ball valve on my wall mount is open, because I'm reflecting compressed air pressure on my lockout regulator gauge. So now that I know that's good, we have our correct lines assembled where they need to be, and my recovery tank's blue valve is wide open. I'm going to begin the recovery. We always start at a slow 10 psi, because if we start at a higher stroke, we can run that same risk of pulling liquid solvent back to the end of the pump. At this point in the extraction, we've reached 40 degrees temperature inside of the collection vessel. That's a significant drop from what we started. About the ambient room and the temperature was 65 degrees. The reason we're losing temperature in the collection vessel is because we're changing the state of the solvent in the collection vessel from a liquid to a vapor. When solvent converts from a liquid to a vapor, it creates cold. In turn, that's going to lower the temperature inside of the collection vessel. So at that point, once we reach down to about 40 degrees, is a good baseline to jump into mode 2 on the water heating system. Now to enter the mode 2 water configuration to start heating the jack of the collection vessel, we need to reconfigure our water lines. So the first step in that is I'm going to take my main water in line coming from the water recirculation unit that's currently plugged into the water import of the expansion filter. I'm going to disconnect that line, and I'm going to reroute that to the water in of the collection vessel. White to white, and then I'm going to use my provided 2-foot jumper hose that comes with the 1300 to jump from the water out on the yellow coating on the jumper, and I'm going to go back to the water in on the expansion filter where I started. And now all we've done is jump the water collection jacket onto the heating circuit so that we're now heating the expansion filter and collection vessel jackets at the same time. Now that the system recovery is complete, all of our gauges on the system are reflecting 0 psi at gauge 1, gauge 2, and gauge 3. At this point, we're ready to use the Haskell to pull all 3 vessels into a slight vacuum, and from there we'll complete the extraction. So as the pump's still running, I'm going to monitor my levels of vacuum in the gauges. Once I achieve a slight vacuum in gauge 1, gauge 2, and gauge 3, I'm going to close all the ball valves from 1 to 3. So I'm going to close valve 1 first, then valve 2, then valve 3, and shut my recovery pump off. So now that the pump is off, we've recovered all the solvent. We're ready to move on to taking the collection vessel off of the extractor and moving on to the next processes. The first thing that I want to do is immediately jump back into mode 1 so that by the time I've got the next run load of material packed, mode 1 will already be ready and recirculating. So to do that, it's just as we did before. I'm going to remove my jumper line. Just let it rest back here. And take my main water line and plug that back into the white water end of the expansion vessel. And now I'm recirculating in mode 1, so all the other operations I have to do, by the time I'm ready to do another run, the expansion filter will already be preheated. Now that the extraction process is 100% complete, we're going to set the extractor up for another run. But first we need to harvest the concentrate off this run and prepare for the next. So first step there is I'm going to remove the red hose from the top cap. I'm going to place that either on my hose rack or wherever I'm storing my hoses. Next I'm going to remove the Brazil hose from the inlet of the Haskell. And I'm simply going to rest that on top of the rack. We can leave one side of this hose plugged in because this is going to be our vacuum line just like this run was. Next, I'm going to unplug one side of the green hose on the collection vessel, and I'm also going to rest this on the rack so that it's off the floor out of the way. One thing that most people forget too is we need to uncouple the thermoprobe connections that run from the collection vessel to our actual thermometer display here. Now we're ready to remove the collection vessel and harvest the concentrate that we just extracted. To do that, I've already removed all of our system hoses that we went over before. I'm going to uncouple the thermoprobe connection so I don't tug and damage this when removing the collector. And now I'm ready to remove the collection vessel. I'm going to use my 4 fingers on both sides of the clamps and use them somewhat as handles. I'm going to use my thumbs on the slip fitting here. I'm going to be pushing down and kind of catching the weight of the collection vessel at the same time to decouple it from the system. Once the collection vessel comes down, one thing I like to do is just gently turn it on the side to get these little drips of water out of the water bodies, because if you send that over to the processing area, sometimes they'll end up getting the water in the product and it's no good. So now that I got those little drips of water out, I'm going to pick the vessel up and take it to our processing table. So now that we have the collection vessel in the processing area, we're just about ready to take the top cap off of the vessel and harvest our concentrate out of it. Before we do that, there's a couple things we need to do. First off, the vessel is still under vacuum from the run, so we need to alleviate that vacuum, bringing the PSI in the collector back to 0. And to do that, we're going to use our purge valve tool. I'm going to insert the purge valve into the green quick connect, and then I'm going to open my ball valve. So the sound you're hearing is nothing coming out of the collection vessel. It was actually atmosphere coming back in, alleviating the vacuum, bringing the vessel back to 0 psi. A rule of thumb, safety-wise, is you need a purge valve inserted in the quick connect with an open valve reading 0 psi to be confident that you're ready to take the clamp off of the vessel. So we have all those conditions here. So next step is we're going to take our system wrench and we're going to use the larger 3/4 ratcheting side to take the nuts off of this clamp and loosen. Once I got one side loose, I can finish it by finger. And I need to use the wrench on the other side to do the same thing. At that point, it's pretty easy just to use my fingers to loosen the nuts. Now that we've removed our high pressure clamp, we can take the top cap off of the actual vessel. When I remove the cap, it's not very difficult. You want to be careful not to bang around the thermoprobe assembly in regards to bending it, breaking it. You want to try to keep that maintained. One thing you'll notice in live runs too is you're always going to have some concentrate stuck to the bottom of the probe. It's pretty easy to forget about, but try to scrape that off and maybe get it into your processing dish or whatever you're using before you move on to the actual collection vessel. Also, when you're resting the top cap, rest it gently on your table surface, just resting gently on the gauge. I never want to rest it on the thermoprobe assembly because that can lead to bending and breaking and having to replace parts. This concludes the brief video overview of the 1300 by Extraction Tech. Thank you for your time and watching the video, and we look forward to seeing you soon.